and the aphelion of the king star points to. It is almost the opposite of Pluto. Here's why. Lass is often referred to as anti-Pluto. 4c. It is an extra-Neptune object located in the Kuiper belt, classified as a discrete object. He orbits the Sun in an elongated orbit. The average distance is slightly greater than the semi-major axis of Pluto's orbit. It was discovered on September 22, 2004 by astronomer Michael. Brown calculated 4c is likely a dwarf planet. However, many astronomers believe, like Salahi with a diameter of 400 to 1,000 kilometers, the albedo is less than 0.2. Objects with a density of 1.2 grams or less per cubic MOA, probably not a dwarf planet. Astronomers believe Varuna is shaped like a rugby ball. The diameter is about 900 kilometers. It is about 1/15 of the diameter of the Earth and 1/4 of the diameter of the Moon, or 1/3 the size of Pluto. The orbit of Pharaoh is close to circular. It is about 43 astronomical units from the Sun. The orbital period is 283 years. It takes about 3 hours to rotate one lap. Varuna and Pluto have the same orbital inclination. The same goes for the direction. Varuna will not be significantly disturbed by Neptune. This extra-Neptunian object is likely a dwarf planet. Despite astronomers, it has not yet been officially classified as a dwarf planet. Ixion was discovered on May 22, 2001, named after a Greek mythological character. He is one of the largest tomorrow-like bodies. That is, Neptune, whose orbit is similar to Pluto. The outer body is the same as Pluto. Ixion also forms a 2 to 3 orbital resonance with Neptune. The latest spectral results show the surface of the Ixion is made of black, composed of a mixture of carbon and toluen. Toluen is an organic substance. The amount of nitrogen content varies. Reddish-brown in color, sometimes purple. The structure is not very clear. Kuiper belt. Start a little further outside Neptune's orbit, 30 astronomical units from the Sun. It ends at about 50 astronomical units. But Kuiper carries a huge mystery. 1 to 50 astronomical units. The strap stopped, ended abruptly. Astronomers call it the Kuiper cliffs. But why such a sudden change in environment? This mystery can be answered by different hypotheses. It may be that the band continues to extend, but the celestial body became too small. We can't see it. But this idea is very similar to our understanding of the solar system. Chen Ying's understanding does not match. Opposite. Due to the complex interaction of the orbits of the outer planets, we anticipate celestial bodies will start growing again at this distance. An even more exciting idea is these celestial bodies. It may have been drawn away by the gravitational pull of an unknown planet. Such a planet, it could be as big as Earth or Mars. It is the 9th planet in the solar system. 1. The possible existence of the 9th planet is very far from the Sun. This raises the question of the number of planets in the solar system. Very likely, there are other planets located far from our star, so much so that they disturb the surrounding celestial bodies, not yet noticed. Unfortunately, it's hard to see anything from that distance, so the mystery has not been solved. Outside the Kuiper belt is another structure called the outer cloud. The idea of the existence of the cloud was first in 1932. Estonian astronomer Ernst Epic proposed it. Then in the 1950s, by Dutch astrophysicist Young, Oort developed theoretically. Oort cloud is named after him. It was proposed comets originate in the outer reaches of the solar system, an extended spherical cladding consisting of ice bodies. This large group of celestial bodies is now known as the Oort cloud. It extends in a spherical shape, radius 5000到10万 AU. The Oort cloud is an imaginary region, located halfway between the Sun and the Heliopoeus. Heliosphere top. It is the boundary where the solar wind is blocked by the interstellar medium. Astronomers believe the existence of the Oort cloud explained why some comets have extremely long orbital periods. A piece of dust and ice. You can stay in the Oort cloud for thousands of years. When some nearby stars pass by, close enough to the solar system, their gravity will blow the objects in the Oort cloud, push into orbit around the Sun. The Oort cloud is the biggest mystery of the solar system. We never seen him is an imaginary region in space, different from Kuiper belt. We can observe large extra-Neptune objects, know where he is. But Oort cloud is very mysterious. Alter said, it is estimated to be more than 50,000 O from the Sun. That is, more than a light year, approximately to our nearest neighbor, 25% of Proxima Centauri distance. So Alter said it was very far away. The boundary of the Oort cloud is roughly at the edge of the solar system. At this distance, billions of celestial bodies in the Oort cloud, the gravitational connection with the Sun is very loose. Therefore, they are subject to the passage of other stars nearby. The strong influence of, it is believed that, disturbance of the Oort cloud. It causes the ice to fall inward periodically, forms long-period comets. For example, Halley's Comet. In fact, astronomers believe the only reason why the Oort cloud exists, it is the source of long-period ice comets. The orbits of these comets are very eccentric, from areas outside the ecliptic plane. This also indicates that the Oort cloud surrounds the solar system. It is not limited to the band-like area around the ecliptic plane. So the Oort cloud seems to be there, but we can't observe it directly. It's so far away. There is so little light. We simply don't have the technology to see it. This means that we cannot prove that it exists at this time. How big if it exists? This is the biggest mystery in the farthest part of the solar system. 1950 Dutch cosmologist Yelt, after analyzing the orbital distribution of comets known at the time, proposed long-period comets originating from a region at the edge of the solar system. The distance is from 20,000 to 200,000 O. If in 1950, Oort originally hypothesized, these objects are the result of an explosion of an imaginary planet. By 1951, his hypothesis had changed, closer to modern conclusions. It is likely that this piece of cloud, formed by the primordial protoplanetary disk of dense gas. The plate appeared again near the still young Sun, at the beginning of the formation of our solar system. So this cloud may now be more than 4.5 billion years old. In fact, the Oort cloud is a continuation of the Kuiper belt. These celestial bodies, it could have merged closer to the Sun. However, due to the gravitational effect of gas giants, they were thrown a long distance. Giant planets indeed, especially during the evolution of Jupiter and Saturn. When they reach a sufficiently large mass, very strong gravitational perturbations will occur. Began a large-scale general star, thrown from the nearest area of the orbit. This cloud is made up of millions of ice bodies. It was later known as the Oort cloud. It is a huge repository. There is a comet body inside, in a star close to the Sun, or under the influence of huge clouds of gas dust. They change their orbit and fall into the inner regions of the solar system. A study by NASA scientists shows the enormous number of these celestial bodies is the result of an exchange between the Sun and neighboring stars. Computer model display. Galactic and stellar tides change comet orbits, make them rounder. This may be the reason why the Oort cloud is spherical. The simulation also confirms formation of outer clouds in line with the Sun appears in ideas in clusters with 200 to 400 stars. The composition of the Oort cloud consists of two parts. A spherical outer cloud. It is 20,000 to 50,000 astronomical units away. An inner disk-shaped cloud. Distance 2,000 to 20,000 Oh. The outer layer is inhabited by trillions. An ice body with a diameter of 1 kilometer and billions of 20 kilometers in diameter. We don't know the total weight. But if Halley's Comet is a typical object, calculated number equivalent to the mass of 5 Earths, stars that sometimes pass by will disrupt the orbit of one of the celestial bodies. Make it like a long-period comet passes through the interior of the solar system. These comets, the track is very wide and elongated. It is usually observed only once. Examples of long-period comets are Halley's Comet and Swift-Tuttle's Comet. Most comets are filled with water, ethane, ammonia, methane, hydrogen cyanide, and carbon monoxide. 1% to 2% may be composed of asteroid material. On the other hand, short-period comets with orbital periods of less than 200 years, moving on the planetary plane from the Kuiper belt. It is believed that the Oort cloud has the highest density in the ecliptic plane of all the celestial bodies that make up the Oort cloud. About 1/6 here. The temperature here is no higher than -269 degrees Celsius, close to absolute zero. The space beyond the Oort cloud no longer belongs to the solar system. In the past, comets were thought to be tailed stars. Comets can be seen in the night sky for several weeks. Aristotle argued, comets are luminous vapors in the atmosphere. Danish astronomer Tycho Brahe realized these objects are farther away than the moon from deep space. Edmund Halley discovered comet of 1682. It is the same as the orbit of comets in 1531 and 1607, hence the same celestial body. Galileo predicted that the comet would return in 1758. The comet follows a very elongated elliptical orbit, orbiting the Sun. The cycle varies greatly. It ranges from a few years to several thousand years. Long-period comets are likely from the Oort cloud, located on the outer edge of the solar system. There are millions of comet nuclei in operation there. Generally speaking, comets orbit the Sun in two different groups. Kuiper and Oort said, a comet with an orbital period of less than 500 years, mostly from the Kuiper belt. These comets are small celestial bodies in the solar system. It is made from a mixture of porous ice cubes and dust particles. A few kilometers in diameter. There is no fixed shape. Their composition since the birth of the solar system. It hasn't changed. This is invaluable to science. Orbiting the Sun along an elongated orbit. Looks like a blurry celestial body. The meeting star is invisible when moving in distant orbits. As they approach the Sun, the ice begins to melt and evaporate under the action of the Sun's heat and volatilize into interplanetary space. As a result, many comets pass by the Sun in close proximity. Takes on a very unusual appearance. Comets grow blue gas tails and yellow dust tails. The tail is thin. It can also be spectacular. Just spreads along the track. If a comet enters the Earth's atmosphere, it's called a meteor. Most comets appear periodically near the Sun. They are all quite dim celestial bodies. The exception is Halley's Comet. It returns to the Sun almost every time. They are all very bright objects. In fact, the brightest, the most spectacular comets will appear unexpectedly in the sky. Many of them may be approaching the Sun for the first time. In rare cases, especially when comets are too close to the Sun. It may break into several pieces. It was then observed as a separate object. All comets have a fuzzy gas envelope. Together with the wisdom nucleus, it forms the head of the comet. Even if comets are close to the Sun, its head also looks like a blurry dot. The most striking detail of most comets is the tail. When the comet approaches orbital perihelion, the tail is the brightest. The heat flow from the Sun is especially important here. Under its influence, gas and dust escaped from the comet into space. Some comets have two tails. One is curved, composed of dust particles. The other is a straight gas tail, extending in the opposite direction to the Sun. The length of the tail of a comet can reach tens of millions, even hundreds of millions of kilometers. So some comet tails were observed, extended nearly half the sky. It is believed that the dust lost by the comet falls into interplanetary space, formation of meteoroids. Later, it collided with the Earth's atmosphere at high speed. It came out in the form of a meteor, a peer. Just particles from the comet's tail also reconstitute interplanetary dust clouds. By scattering the Sun's rays, a phenomenon called zodiacal light is produced. The nucleus of comets is sometimes inside the envelope. Looks like a bright star-like object. Even the largest telescope cannot distinguish details. Comet nucleus. It has been studied in detail by spacecraft approaching the comet. NASA's Deep Impact spacecraft in 2005 collided with Comet Tempel 1, returned surface images. The mass of comets is small. It is about 1 billion times smaller than the mass of the Earth. The density of matter in the tail is almost zero, so they don't affect the planets of the solar system. The most famous of these is Halley's Comet, returned to the Sun once every 76 years. The last time it approached the Sun was in 1986. History records our ancestors' fear of these celestial wanderers. In ancient chronicles, can often be found. There are records of bright comets in the sky, and the connection of these phenomena to events on Earth. For example, fires, wars, and even personal deaths. This collision is a good one, and a fairly sufficient example of research is July 1994. Shoemaker is listed as a fragment of Comet 9, collided with Jupiter. Fragments of this comet, at a speed of 210,000 kilometers per hour, bombard Jupiter's dense atmosphere. During the impact, incredible kinetic energy of fragments unleashed in a powerful explosion. Some of them turned into fireballs larger than the Earth. As a training exercise, in case an asteroid threatens to hit Earth one day, NASA's DART probe on September 27, 2022, it hit a double asteroid head-on. The impact was just enough to bring the asteroid away, push into an orbit slightly closer to its companion. This successful mission is a first for NASA. It is part of the Planetary Defense Plan, aimed at developing solutions for deflecting asteroids if they threaten the planet. With the geographical significance of our Earth, to talk about the boundaries of the solar system, not very accurate. In space, all boundaries are relative. It is determined with the help of data recorded by many instruments. Everyone knows that the Sun is the source of light and heat. But other than that, the Sun also constantly releases huge plasma streams. This is called solar wind. To answer the question of where exactly the solar system ends, you need to understand where the solar wind flies and where the Sun's gravity stops. Dominant particle stream. It spreads at a speed of about 1.5 million kilometers per hour to create one, similar to the atmospheres that exist on some planets. This structure is called the heliosphere. Therefore, The area that is continuously affected by the solar wind is called the heliosphere. The boundary of the heliospheric layer is called the heliospheric top. Situated, a place about 100 astronomical units from the Sun. About where exactly the solar system ends. The question of where interstellar space begins. There is no clear answer yet. In determining the relative boundaries of the solar system, there are two main factors to consider: the distance from which the solar wind ends, and the distance at which the star's gravity extends. At a distance of 60 to 70 astronomical units from the Sun, due to interaction with interstellar gas, the solar wind begins to slow down rapidly. At the top of the heliosphere, solar plasma flow, completely balanced by the pressure of interstellar gas. However, the Sun's gravity prevails at greater distances. Some scientists believe the Sun's Hill ball, a sphere dominated by the gravitational influence of celestial bodies, extended to 125,000 O. Therefore, this distance can be increased, called the true edge of the solar system. The famous American spacecraft Voyager 1 and 2 left Earth in 1977 to study giant planets. Per spacecraft are equipped to measure the magnetic field through which it passes, and particle instruments. Since then, both detectors were traced, the path to interstellar space. Therefore, it also reaches the heliosphere. However, attempts were made with two probes, Voyager 1 and 2, to understand the entire heliosphere. It's like trying to use two weather stations. The weather is the same as the weather in the entire Pacific Ocean. Therefore, in order to better study the heliosphere, the two probes work with the interstellar boundary probe. The latter is a suitcase-sized satellite, weighs 80 kilograms, launched by NASA in 2008. Since then, he has been orbiting the Earth. Equipped telescopes observe the outer boundaries of the heliosphere. IBEX satellite, capturing and analyzing a class called high-energy, particles of neutral atoms. They crossed his path. These atoms, where the interstellar medium collides with the solar wind, form some atoms that return to the center of the solar system. Therefore, by collecting many of these individual atoms, it is possible to create an image of our heliosphere layer from the inside. 2012 Voyager 1 crosses the heliosphere. December 2018, Voyager 2 did the same. But nevertheless, these devices are still sending signals to Earth. They found cosmic rays outside the heliosphere. The intensity is about 3 times that of the heliosphere. In addition to Voyager 1 and 2 missions, other devices also operate at the edge of the solar system. For example, Pioneer 10, Pioneer 11, and New Horizons. These vehicles will eventually leave the heliosphere as well, enter interstellar space. Just like Voyager 1 and 2. In 2006, NASA launched the New Horizons probe. The main goal is to study dwarf planets, Pluto and its moons. He arrived at the end of 2015. For the first time, the surface of the former 9th planet is shown. Now he is heading to the end of the Kuiper belt. Go check the celestial bodies there. In space missions, we still haven't reached the Oort cloud. There is even further. Voyager 1 is the farthest probe from Earth. The instrument is 23.3 billion kilometers away from Earth. According to the current acceleration, spacecraft that are now in interstellar space, it will take another 300 years to arrive. Alter said, it will take more than 30,000 years to come out completely. Pioneers 10 and 11, Voyager 2 and New Horizons will follow. But given that the detector has very little energy left, up to 10 years, when they arrive, the data will not be able to be transferred. Therefore, the main difficulty of the study is that the distance is too far. The time the probe arrived there, Centuries have passed for us. At the moment, we can only observe comets. An interesting fact is, tens of thousands of years later, the probe encounters other stars. For example, Voyager 1 and Herald 11 will encounter Proxima Centauri. Pioneer 10 and Voyager 2, you will encounter a small red dwarf, Ross 2,482,025. NASA will launch interstellar mapping and acceleration probes, a camera that captures high-energy neutral atoms on an IMAP, higher resolution, more sensitive than the camera on the IBEX. When defining the boundaries of the solar system, it is necessary to indicate what can be considered its borders. So far, 3 hypotheses are considered. According to the first hypothesis, the radius of the solar system, considered to be the distance to the aphelion of the farthest planet, that is Neptune. In this case, the radius of the entire system will be 4.545 billion kilometers. As for the second hypothesis, scientists believe the radius of the solar system, defined at the end of the farthest observed celestial body, currently Sedna. In this case, the radius of the entire solar system will be 143 billion kilometers. To simplify calculations and understand the size of the solar system, the unit of measurement should not be in kilometers. Astronomical units should be used instead. Know that 1 astronomical unit is equal to 150 million kilometers. That is the distance from the Earth to the Sun. In this case, half of the Sedna orbit. The diameter is 955 astronomical units. Finally, according to the third hypothesis, the radius of the solar system is thought to be to the edge of the heliosphere. In this case, the radius of the entire system will be 90 AU. Thanks to new data, experts have created a 3D map of the solar system. After 13 years of work, measurement of 3D maps, it is made up of a space called the Interstellar Boundary Probe. Research satellites collected. He was launched in 2008. Studying satellites behaves like bats in a cave. It's just that sonar or animal sounds are not used. It is the solar wind. During the entire solar activity cycle from 2009 to 2019, the device measures, sweep it towards the particle stream of interstellar space. At the same time, it tries to capture atoms returning to the interior of the solar system, far beyond Neptune's orbit, a place of about 60 astronomical units. The solar wind collides with interstellar plasma. This interaction not only slows down the particles emitted by the sun, a stable stream of high-energy neutral atoms is also produced. It is rather faint, but it can be perceived, and most importantly, it has a strictly unique nature. The journey of the solar wind from the star to the boundary of the heliosphere, it takes 226 years. By carefully measuring solar activity and high-energy neutral atomic streams, scientists compare these two multidirectional particle streams. For the first time, a 3-dimensional map of the heliosphere boundary was compiled. Hence the development of 3D maps. More data on the heliosphere has been revealed, especially the inner layers where the sun and planets are located. The shape resembles a spherical layer. According to scientists, it extends about 90 astronomical units in all directions. They also believe the shape symmetry of the outer layer is much worse. The sun is actually constantly moving through space in the direction of collision with cosmic radiation. The outer heliosphere extends about 110, but in the opposite direction, it is much longer, at least 350 astronomical units. This asymmetry is caused by the movement of the sun along the Milky Way. According to scientists, in the interstellar medium and the inner heliospheric layer, there is a large amount of plasma or charged particles. and the inner heliosphere is quite round. It is a barrier that blocks the passage of these plasma flows. This is the same effect as water flowing around rocks in a stream. There is some debate about the exact shape of the heliosphere. However, scientists agree that it has several layers. Let's look at the layers inside out. The first is the layer called terminal shock wave. Represents the deepest layer of the heliosphere. It surrounds all the major planets of the solar system. Here the solar wind from the sun, at speeds of more than 1 million kilometers per hour,